Welcome back. It's good to see you again. Today we're going to continue on electricity. In the last lesson, we learned about electric current. Today we're going to move one more step to introduce a new term and concept, which is related to the battery. All right? Battery is actually like the energy source of things. Okay? So in electricity, we refer to electric energy with these two terms, EMF or potential difference. So first of all, let's tackle the first one, EMF. What is EMF? EMF is actually a short form for electromotive force. Okay? So from the term itself, you can kind of guess what it means. All right? So the first word, electromotive. So motive talks about movement. Electro refers to electrons, and then force. Okay? So electromotive force is what it means is the work done to drive what? Per unit charge. Okay? To drive per unit charge where? Across a circuit. Okay? Alright? So you see over here, to drive per unit charge, there is the electron. Alright? To drive, which is the movement. Okay? So a battery has electromotive force. This will produce, the chemical energy inside will produce an EMF that drive the electrons around the circuit. Let me draw this out for you. So can you still remember this symbol? Right? So this is a dry cell or a battery. Alright? So, and then this is a closed circuit. Okay? So the dry cell will produce a EMF that's pushing the electrons around the circuit. So if I say that this is 10 volts, so what this means is that 10 volts, what it provides, it provides 10 joules of electric energy. Alright, okay, or you will do 10 joules of work to drive 1 coulomb across a circuit. Okay, alright, so how much work is done? 10 joules for each coulomb of charge. If I have 2 dry cells, each one 10 coulombs, so I stack them up next to each other, which you will learn the term series later. So let's say I say this 20 volts, okay? What is the amount of work done when you drive across? Okay, we can also use a formula. E is equals to W over Q, alright? So E here stands for your work, your EMF, electromotive force. So this is your work done, which is calculated in joules. Charge is in coulombs, all right? So your EMF is calculated in volts, or in short, V, okay? All right? So 20 volts over here. So E is equals to W over Q. So if E is 20, W is what we want to find. Q per unit charge, 1. So W is equals to 20 joules. So how much work is done to drive a charge across? 20 joules. Okay? Alright? So I hope you get that. Next is the concept of potential difference. Okay, let me draw another circuit here. Alright, so we have a dry cell. Let's have a closed circuit. Alright, okay. Now I'm going to break up the circuit into parts. Okay? So let's say I call this point A, this is point C, and right in the middle here is point B. Okay? Okay. What is potential difference? Potential difference, or in short, PD, okay, is the work done to what? To drive what? Per unit charge. Okay, drive per unit charge across where? Across 2 points. Okay, alright. You compare this definition with this one. Okay, what is the key difference? Work done to drive per unit charge across a circuit, across 2 points. So that is the difference. So technically their formula is also the same. PD we use V is equals to W over Q. Alright? Okay. So what this means is quite simple. Alright. So just imagine this is a running track. Okay? All right, so I have a runner that is like running. Okay, all right, so it's running. So to run, finish the whole track, let's say if the runner uses 20 joules of energy, all right, have done 20 joules of work to run through the whole track. Let's say if B is the midpoint, so how much, and if he runs at a consistent speed, okay, of using his energy sources, how much, if to run finish 20 joules, so to run halfway, how much work has he done? Yes, you're right, you just split this into 2, then you get 10 joules. So from here to here is 10. And then for the remaining, it will also be 10, okay? All right, so take this concept, put it into potential difference. So PD, I can say potential difference from A to B is equals to 5 volts. All right, means that the work done to drive the charge from A to B is 5 joules. All right, and let's say if I say the EMF, which is the total, all right, energy source to drive across a circuit is 10 volt. And then if the PD over here is, PD is equal to 5 volt, all right, from here to here. Then what is PD, potential difference from B to C? How do you find? You take the total, 10, minus away this part, 5, and then you get 5 volt. All right, so PD from B to C is also 5 volts. Conversely, if you know the potential difference from here to here, and then from here to here, all right, you add them together, all right, which is the entire circuit, what do you get? You get EMF, all right? So I hope you get the concept. So both EMF and potential difference is about the work done to drive charge. The main difference is this is across the entire circuit. This is across any 2 points. So I can have a potential difference from here. Let's say I can call this maybe like D, okay? All right, and then if this is like totally half, then most likely if this is 5 volts, then here half will be just 2.5 volts, okay? All right, we'll elaborate more on this concept in the later chapters. So what you need to know and remember today is the definitions, the differences, and this main formula, okay? All right, and this one. Okay, so hope to see you in the next video.